Hey, happy Sunday. This is PFG Live from the Bat Cave. Actually, the Flat Cave. How are you guys? This is the only podcast that asks, can we torque? We're getting reports from Mr. Tucker, 90 degrees Fahrenheit, partly cloudy in the Buffalo, New York, a stone's throw from Avengers Tower. Evils is reporting from Belgium, where it is 29.3 degrees science, 13.2% relative humidity. Oh, no, 13. It's a bunch of numbers. Dale says it's 16 degrees science and overcast in the Canada. Welcome aboard, sir. That's nice and cool. CJ Stevens reports 92 and lots of sun in East Tennessee. Welcome aboard, sir. Carl Tauber in the People's Republic of Rhode Island reports 85 degrees, hot, humid, hazy, all the H's. Arsted says it is way too hot in Peoria, Illinois, but is it worth it? I think so. Here in the Windham, New Hampshire, it is 88 degrees Fahrenheit and 60% relative humidity. Josh has taken the easy way out, and he's given us 72% relative humidity. That looks like 18.5 degrees science and other numbers. Thank you, sir. Graphical weather delivery. At the Manchester Airport, that's the Manchester, New Hampshire, not the other one. Winds are 300, 15 gusting to 23 with 10-mile visibility. Clouds are scattered at 4,900. Temperature 33, dew point 20, altimeter 2986. And the remarks are meaningless. Welcome aboard. We'll have everybody roll in here, I'm sure. Last week was Father's Day, but this father decided we were going to have a PFG Live, so we did, and it was a good time. Let's see. What else, what are you guys working on these days? I know that Josh is working on his squareness comparator, which is pretty cool. We're looking forward to seeing that thing finished, and that's based off a Tom Lipton design. Robin's here. Welcome aboard, Robin. Evils is spot welding chainmail. So when you say spot welding, Evils, you're actually using a TIG torch, right? And you're doing that little gap in the ring. I believe arc spot welding, just short pulse TIG welding, I think we'll call that. And I saw some cool pictures from him on the chainmail project. That was pretty neat. So yeah, I haven't done any welding in quite a while. I probably shouldn't say that out loud because the next thing that happens is I usually get a welding project come in. But we'll see what happens. In the Discord right now, I welcome Tucker, Dale, Josh, Pixel, Paul Morley, Evils, Carl Tauber, Robin, Arsted, Kyle Kirsch, and somebody just jumped so that I couldn't see him. It's okay. We're not judging. And let's see. Over on the YouTubes, so far we've got Evils. Evils is in both places. CJ Stevens and Mr. Carl Tauber in two places also. Welcome aboard. So summer is here. It was the summer solstice. Yesterday, I think officially was the summer solstice, and it's all downhill from here, folks. Oh, that was Harvey Newman. You jumped. It's okay. It's hard to keep one eyeball on each screen. I totally understand. So we're expecting here in New England, well, throughout New England, but I know for sure in New Hampshire that Monday and Tuesday, I think Tuesday is the peak. We're going to break 100 degrees Fahrenheit, and we might do it on Wednesday also. So there's all sorts of warnings out for hot temperatures and air quality and all that kind of stuff. I'm just going to be hiding next to my air conditioner. So that is the plan. Max is here. Welcome, Max. Nice to see you. We were just talking, weren't we? Max sends me pictures of his very tasty dinner that he was cooking out on the deck, which looked quite yummy. We were probably eating chicken at the same time, just saying. And now Kyle's back in Discord just trying to confuse me. So this week, I started thinking about torque, and it actually wasn't this week that I started thinking about it. It was a couple of weeks ago, but as I was sitting in the comfy chair thinking about the PFG.Live, I realized that this is a topic that we've never really covered, and it's important, and there's some surprises in store. Test Room 2003 is here. Welcome aboard, sir. From Oostkapelle, Netherlands. He says it's 23 degrees science and 50% relative humidity. You're almost standard. Just a couple of degrees warmer than standard. There it is. He's gonna torture me with pictures of yummy food on the skillet. You're worse than A-bomb with the yummy food on the skillet. Anyway, so today we're going to talk about torque. We're going to torque about torque. It's been a busy week. I had some interesting experiences this week with trying to finish a project that's been going for a while. Yes, it's the project that has the squiggly bits in it, and we're in the paint shop right now. So the units are in the paint shop and they got painted. And I get a call from the paint shop says, I was scheduled to go pick them up, and the paint shop says, yeah, they're still not quite dry. They're a little tacky. Then I realized he was talking about me, that I'm a little, just kidding. So we decided, and by we, I mean the paint shop and me and my customer grumbled, but we had to wait until Monday for that paint to dry. So, hey, when it goes over 100 degrees, I'm pretty sure it's gonna cure. Yeah, Protium says they better not screw them up now. Yeah, Protium helped me on this project, and so okay, I will tell you my secret recipe for projects like this, because I do a lot of low volume projects in the antenna world, which is generally the antenna world is generally upstairs. But that's not true either, because there's a lot of machining that goes on. So if I have to make one of something, I always make two. And if I have to make and deliver two of something, I always make at least three. In this case, I made four. Now, the reason I do that is simple. And then, of course, my subcontractors, I'm looking at you there, Protium. My subcontractors, they make five. So at each step of the process, if you have something fall out or get lost or get damaged, you can still make the delivery. It would be awful to have an order for one, make one, and then have one mistake prevent you from shipping that. Now, I recognize that in very high expense projects, that could be hard to do because of the cost of materials, but we try to build in enough margins so that we can do that. Art that makes art. Welcome, sir. Art says, art that makes art, which is actually Wes. He says, as a machinist, everything always gets ruined at the very end. Right. Dale says 2 is 1 and 1 is none. So that's why we're at the paint shop. What could wait, hang on. Somebody else does it better.
What could possibly go wrong?
That was pretty chewy. What could possibly go wrong? So we're at the paint shop. So now I have 2 at the paint shop, but I have 2 sitting over here. And it was very tempting to give all 4 to the paint shop, but I didn't do that. Even at the risk of spending more money on paint, I gave 2 to the paint shop. When those 2 are done and finished and shipped out the door, then I have the option of sending the other 2 to the paint shop on my nickel and going from there. I think that's a pretty important thing to realize. Now, if you're in production and you're going to be making and shipping 100 things or 1,000 things, it's a little easier to not worry too much about that. But when you're talking about high value items that you're only delivering a couple of, you got to think that one through pretty hard. So downstairs in my in the shop, if you came and visited me, you probably would have seen this magnificent 15-inch diameter Cassegrain reflector antenna that I did for a client, and that was quantity 1. Well, I made quantity 2, and now the second one is used as a piece for marketing, or showing capability, and that worked out pretty good. So yeah, never make one when you can make 2. So and in fact, Proteum, you'll see some of your handiwork here a little later today. So we're going to talk about torque, and in particular, we're going to talk about fasteners being torqued. So in the thumbnail for today's live, I showed some goodies, which I think I'm going to show a different way. We'll go over to the so-called whiteboard so you can see them a little bigger. I want to say thank you to Dale for 2 of these pictures: the red torque meter and the somewhat large socket head cap screw on the left. The socket head cap screw on the right is for the purposes of the picture stuck under my thumbnail. Anybody want to guess what the 2 sizes are of those 2 screws from the picture? And Dale, you cannot guess. Yeah, no, I know you know. You can't guess. Anybody want to take a shot at it? We have prizes. Okay, Evil says M1.5 and M30 left hand. Actually, I don't think it's left hand. I think that's a right hand. Is that a left hand? Let's see. Yeah, that is a left. It's a left hand, I think, because I flipped it. It's not actually in real life. It is not a left hand. Let's see. Paul Morley says big ass 3. That's a good guess. We're closing in on it here. Evil. So the answer is CJ Stevens says M3. Actually, that's close. So the big one, according to I actually wrote it on a card. It's a 2 UNC. There we go. 2 UNC 4.5 threads per inch is the big one. That's 2 inches. And the little guy is 256. It's a number 2 screw, 256, 56 threads per inch. And the funny thing is, both of these screws, when they get put into their final application, need to be properly torqued for their application. And how you get to the point of being able to know how to torque them and have the right tools for torquing them is non-trivial. Let's see. Give me 1 second here. I'm just going to hit a button. Okay, and we're back. So we use torque wrenches in the shop a lot. Yeah, Evil says the big one is just give her all you got. Well, actually, even for the big stuff, maybe even especially for the big stuff, there are torque wrenches, and there are specifications for the torque of a fastener. The pictures on the right are different torque wrenches. So we have in the far upper right is a cute little torque wrench, which I'll show live here. That is measuring in ounce inches, I believe. Immediately to the left of that is a Tecton 1/4-inch drive torque wrench, which I really like. We'll talk about that in a minute. Right below that is a Weha set for a screwdriver torque tool, and then to the right is a big torque wrench that is of substantial vintage from Dale's dad, I think. Am I getting that right? Which is pretty cool. And that measures 300 inch-pounds at its top end of the scale. The big one is torque. They're all just measuring torque. Let me show you the littlest one because I have it here. If you're on audio, I'm sorry, but this one is made by a Japanese company, which I don't have the name of. Oh wait, it's on the box. It's Tonichi. And there's a story about my acquisition of this lovely instrument. I believe this was used for calibrations, but really on one side there's a 3-jaw tool chuck. It's pretty standard stuff. And on the other side is the scale. And it's really very delicate. And the top of its range is... if we look at the scale here, the top of its range is 18 ounce inches. Protium says Tonichi makes some good stuff. Really like that. So when I had the opportunity to pick this up, I did. And here's how this occurred. I looked this thing up. This is at the time, and this was a long time ago, this was about a $450 tool. I was on Facebook, and of course, Facebook Marketplace is a dangerous place to be. And on Facebook Marketplace, a guy was listing a Kurt 688 Vice for, I think, $200. And that sounded pretty good to me. So I contact this guy on Facebook Marketplace, and we meet at the post office parking lot because I didn't know who this guy was. And sure enough, here's this Kurt 688 Vice in absolutely primo condition, like primo. So he said, I think it was $200. So I peeled off $200 and we traded it. And then he says to me from his vehicle, he yells at me, "Hey, I've got something else you might be interested in." And I said, "What's that?" And he brings out this Tonichi box, and he opens it up, and I recognized it as this lovely, unused torque wrench with a calibration sticker on it. And I said these words to him. I said, "Look, I think he asked me for an amount of money. I think he said $100 or something. And I said, look, I am sure it's worth that to someone, but it's not really worth it to me. I said, don't take this personally, but I'd give you $20 for it." And he said, sold. So I think I did okay on that particular deal. So I get this thing, and not only is it in exactly the condition I suspected, which is essentially never used, but I notice a sticker on it that has the name. I'm just going to cover up the name of the company. It has the name of a client that I used to have, which is under my finger there. And I said, what's the story with these tools? And I did not tell him that I knew where this stuff was coming from. He said, oh, they went bankrupt and they just walked out of the building, leaving the entire machine shop behind. And his job was to sell all the stuff on behalf of the landlord. So that's how he was doing it. So it's kind of funny that I have one of my former clients' tools sitting here. It's kind of a riot. And if you think you work for that company that I'm telling the story about, you can contact me. Yeah. So that's the lowest torque measuring device that I have, is that little guy. And then probably the oldest thing I have for measuring torque is this half-inch drive. You know, you guys have seen this. This is a Craftsman. I guess they call it a torsion beam torque wrench. And as you torque it, the little needle stays put, and the bend in the rod, and it's about a 14-inch, 16-inch rod. The bend in the rod indicates the torque, which is on this little scale at the bottom. And this was your typical Sears, you know, Sears and Roebuck, walk into Sears, Craftsman tool kind of thing. And for big stuff, that was probably adequate. And then I ended up buying one of these. Let's see. This is a... Who made this? This is a Husky. And this is a Husky with a 3/8 inch drive, and this is very common. You guys have seen this before. And you basically pull back the locking ring and you turn the screw, and you can set whatever torque you want. And then when you hit the torque value, it goes click, and that's my big torque wrench in the shop. And finally, also in that picture, you'll see this set from Wera. So I have a project in-house, the very one I was just talking about, and I needed to tighten a few screws. Let me just show you. Again, if you're on audio, you'll just have to picture this in your mind. So here's the cover plate for this device that I am finishing up, and you can see it has a zillion holes in it. Well, this because it's got little microwavy kind of chambers and stuff. This has 44 440 screws. Proteum says it's too shiny, can't see. You know why it's too shiny, Proteum? Because you made it shiny. This is from Proteum, and it is absolutely stunning. And the parts that got done are equally. When I say got done, the production parts. This is a setup part. The production parts got chromated, and they're gold. They look like they're made out of gold, and the finish is glorious. So it has 44 440 screws, which I think is a little bit of alliteration, and 24 632 screws, and they needed to be correctly torqued. The engraving is not getting filled, sir. The engraving is just to identify stuff. But the paint shop said that it looks really nice. I haven't laid eyes on it yet, but they said that you can read all the engraving, and that's pretty cool. So in order to tighten up 44 440 screws, I bought this Wera set because I couldn't find one of my older tools. And the Wera is a quarter-inch hex drive tool. And again, you pull back this locking ring, and it's got a scale on the shaft, which you could just see right there. Okay, so you pull back on the push forward, pull back. You pull back on the shaft on this locking ring, and then you turn it. You turn this guy, and you can set the torque. Now, there's a very important feature about these that I discovered, and that is that when you put a quarter-inch tool in, this sliding collar locks the tool in. This is very important because as you're going around torquing a bunch of stuff, if you have this locking collar, your tool doesn't get yanked out, and which wastes a lot of time. So I'm very happy with this set from Wera, and it comes with 3 different torque wrenches, 2 that look like this and 1 that's a pistol grip, and it covers 3 different ranges in the torque scale. For example, this one is set to 2.1 Newton meters, and this one is set to 1.2 Newton meters for the 2 different screws. So this is a nice set. After putting some hours on it, I could recommend it. And those are some of the tools in the shop for setting torque. So let's talk a little bit about why do we do this? I think as machinists and engineers, we put stuff together and we know about torque, but did we ever stop and think about torque? So I did a little bit of research, especially for that project, because I wanted to know what I should torque those screws to. And in particular, I was concerned about the 440 screws. They're pretty small, and I didn't want to strip them out, right? That was a fear because they're pretty small. And I wanted them to be as tight as possible because of the job they're doing. They're doing a forever job. So once this unit is all put together, it's nobody's going to unscrew that screw forever. Okay. So in my research, I found a paper from NASA. It's a NASA publication. I have put the link to this in the description of the video, and it's also in our reference channel on our Discord server. And it's entitled Installation Torque Tables for Non-Critical Applications. What is a non-critical application? So when you're dealing with NASA, a non-critical application, roughly translated, means nobody will die if it fails. So there was a very interesting introduction in this paper where they say the following torque tables were developed with the purpose of having a proper mode of reference when tightening fasteners, when loading is not a concern and critical measures are not necessary, i.e., nobody's going to die. Usually the indications when tightening under these conditions are just, quote, hand tight, close quote, or, quote, wrench tight, close quote, or, quote, snug, close quote. However, these are not accurate designations since they have so many variants between person, location, etc. So basically, they came up with these tables. Proteum asks, as an engineer / machinist, etc., how dirty does it feel to design and make a non-serviceable item? It's funny you should ask that question. There's my answer to that has two pieces. One piece is, oh no, I know the application and I know what my client needs, so I'm going to be super careful about this, especially because you can't adjust it. You can't fix it, and once it goes together, it's done. So it might as well be something going into space, right? But of course it isn't. But the second half is that as I was closing these things up and putting the screws in for the last time, I was starting to think I should engrave some things in here for posterity, for when the archaeologists find this stuff and open it up. I did not, but that was a thought. Evils says there's a joy in making something that is immutably perfect. And one day I might do that. But this is within tolerance. This is within tolerance. Okay. So let's I'll give you one more. Well, we'll get back to that table in a second. Let's talk about torque and why it's important, why NASA decided that Snug was not good enough, and what it all means. The purpose of a fastener, there's actually a couple of potential purposes, but generally it's holding two things together. I know that sounds super simple, right? It's holding a cover on a housing. It's holding a bearing block to a structure. It's holding a structure together. It's holding one structural member to another structural member, and it's squeezing two parts together, and that's the purpose of the fastener. So in our fasteners, in our threaded fasteners, typically you want to hold it nice and tight, but you don't want it to strip out. That's one end of the spectrum. And you don't want it to be so loose that it fails to do its job. There are some things that require very special considerations, like, for example, pressure vessels. So if you have a lid on a pressure vessel that is held on with a bunch of bolts, and you tighten all those bolts, but the pressure in the pressure vessel stretches the bolts to the point where you don't have a seal anymore, and whatever is in the pressure vessel gets out, that could be very, very bad. Okay. Another potential place is the other way around, which is where, you have an underwater apparatus, and you want to keep the water out. So you want these bolts to be holding the thing in, and if the bolt breaks while you're underwater, that could cause a bad day. So somewhere there's an engineer who's designing a thing, and we're not looking at this from the engineer's perspective at any depth, but the engineer is saying, I need this much pressure between these two things, so I'm going to pick a method of fastening. And I think to fasten these, I'm going to use a screw, and that screw has to make this much pressure. So that starts to limit what screw, what class of screws and what size of screws you get to use. But the important thing is, we haven't even gotten to torque yet. The important thing is squeezing it together the right amount without breaking forever. Okay? When you think about threads and threaded fasteners, if you just unspool the thread in your head, what you have is a wedge going under a thing, right? You have a thing, and then you have this wedge, and the wedge is being forced under the thing and lifting it up. That's a simple model of what's going on when you tighten a threaded fastener. If you have a coarse thread, then the wedge is a high angle wedge, right? It's like a chisel. When you have a fine thread, it's like a razor blade going under and lifting it up. Absolutely. Yes. I'll read what Testroom says. Testroom 2003 says, torque to get the right tension. Torque is only an easy derivative. For accurate applications, you tension the rod and lock them, i.e. cylinder head tension rods on large diesel engines. Beautiful. So we're going to talk a little. We're getting toward that. So in my research, I discovered a couple of interesting things. The most important thing is that the reason we torque a bolt and get it to a certain value of torque is to put the fastener in tension. Okay, we're literally stretching the screw and yanking down on whatever we're screwing down with a certain amount of tension. That screw is a spring. Okay, you're literally stretching it. And what we care about is how much we stretch it. We don't care about the torque, with one minor exception. But we don't care about the torque. We care about how much we stretch it. So when we torque it to a certain value, what we're really saying is, I am going to get the stretch I want when the torque is this value. And that's why we have torque wrenches. That's why we talk about torque specifications. In my reading in the NASA paper, they said something very interesting. One of the things they define in their tables is what's called pull-out load. In other words, how much do you have to pull on the screw in order to pull it out of its threads? So this depends on the material properties of the screw and the material properties of the threaded thing. Now, in the case of that paper, they were assuming that the screw is stronger than the material. And in fact, they limited it further to stainless steel screws, which was good for me because all the screws we're using in my project were stainless steel screws. But they said something that's quite interesting. They said as long as your thread engagement is greater than 1.5 times the diameter of the screw, you will be limited by the screw strength. In other words, the head breaking off the screw rather than pulling the threads out. If you, for example, have less than 1.5 diameters engagement, then you can pull the threads out before the screw breaks. That was an interesting thing I discovered. We're getting to that, Proteum. You keep guessing what I'm going to say next. So that's all well and good. But what are the factors? How do you get from torque to the stretch of the fastener? Well, the first thing you have to do is you have the thread and the thread pitch, which in our analog to a wedge getting shoved under a load, it's the angle of your wedge, right? So that's one consideration. Another consideration is the friction between the threaded portion and the fastener. So you could have very highly polished threads, or you could have kind of hardware store threads, and they're going to have different frictions. That difference is going to show up in the torque. So that's another variable that you have to take into account. Another variable you have to take into account is, as Proteum pointed out, the lubrication. Are you putting any gouge on the threads? Because if you put oil or grease on the threads, the friction's going to go down, and you're going to arrive at your torque value with a higher tension in the fastener than you would have otherwise. So, lubrication. Now, interestingly, locking compounds, we're all familiar with our favorite Loctite. My favorite saying is that if you want something put together strong, you TIG weld it. But if you want to put it together really strong, you use red Loctite. So, we will frequently use a thread locker like Loctite. Well, Loctite, before it cures, is a lubricant. So that's a consideration also. You might have a hard plastic locking material involved. That's going to also change the torque. So all of these things add up to affect the torque value for a given tension in the screw. And those are all important issues. Different material screws can handle different amounts of tension. And if you have a critical application where you need a certain amount, if you use the wrong grade, like I was talking with Dale the other day about different grade bolts, and there's a table in one of our other good books here, and we're going to be pulling some quotes out of Machinery's Handbook. There's a table for the different grade bolts and what their fatigue limits are. And if you need a certain tension, you may have to go to a different heat treatment or a different material bolt. Again, the torque is going to get affected by the material properties and the friction. So those are all parts of the equation. Well, what about if you what if you say, well, look, I want to measure tension directly. Like, I don't want to have all these steps going from torque to what the tension is in the fastener. Believe it or not, and I should not have discovered this because now I want them. There are bolts. Now, usually they're very big bolts, I don't know what size they start at, but there are bolts with little indicators in the heads. Some of them just have a little color code, like you could see a red dot or no red dot. Some of them actually have a scale, and the ones I just put up on the screen are from Max Bolt, or the brand is Max Bolt, and they actually have a little scale. So as you torque this fastener, and as the fastener stretches, okay, which we don't think of enough, there we go, smart bolts. You actually get an indication in the head of the bolt. Now, Protium just put up on the screen a similar thing. These are the guys that I was thinking of with the red dot or the black dot. These are called smart bolts from DTI. Same thing. They're literally measuring the stretch in the fastener. So this cuts out all sorts of errors in that tension measurement that you really want. So you're not really dealing with torque at all. Don't go pricing these things unless you're seated, unless you're comfortably seated and your blood pressure is normal, because they do not give them away. There are other devices out there that are like crush washers, which I think are also used in a slightly less technically savvy approach to doing the same thing, and that's fair. Carl says, why are main bearing and head bolts in diesel engines restricted to single use? Outstanding question. Okay. So think back to your vast knowledge of stress versus strain curves in metals. And let's see if we could do this verbally. Stress versus strain. So if I put some stress on a metal rod and I start stressing it, which is tension. We used the word tension before. I'm going to measure how much how much pressure it takes to move it a certain amount, and the move it a certain amount is the strain. If I take a piece of metal and I put a little bit of stress on it and get a little bit of strain out of it, it's linear. In other words, if I put 1 pound, I get one amount of movement. And if I put 2 pounds, I get 2 amounts of movement. And that's a straight line, linear stress versus strain curve. But you know that eventually, and the same thing happens in bolts. If you yank on a bolt with a certain amount of tension and then you release the tension, it recovers. Okay? It's in its linear range. So it's below well below the fatigue, not the fatigue, the ductile limit. Okay. However, as you go higher up that curve, you actually will start to get into the yield of the material, and the designers, especially with heads and stuff, they want you in that region because they want that bolt to have a high amount of tension under all temperature conditions, and they get that by getting you into that region. Okay. Well, once you're in that region, when you unbolt that thing, you stretched it permanently. You got into the yield area of that curve. So that is, I think that's the answer to why they restrict it to single use. Because properly installed, and of course we're talking about torque, properly torqued, it is going to permanently deform the bolt. That does not make it weaker as long as they do it to the right number. It makes it exactly where the designer wants it. But it is permanently changed, and that's the answer to your question, Carl. Oh, here we go. Pixel says they also apparently make tension indicating washers that squirt out orange goo when they're to spec. Excellent. So that's a nice low-tech version of these fancy bolts. Again, they're measuring tension directly. They're not measuring torque. Okay, Proteum says, I'm looking at weird torque plans for car stuff. One that stood out is the following procedure. Number 1, torque to 111 foot-pounds. Number 2, torque to 221 foot-pounds. And then, they move it. Torque everything to 111, and then go around and torque them all to 221. Is that what they're doing? Yeah, and those were probably diesel engine cylinder head bolts. So that's an interesting application. I hear this a lot, that in those type of applications, the bolt gets into the yield region. Dale says, I also used bolts that have a hole drilled. Yeah, a hole drilled from the head to the middle of the threads, and then you use a depth mic to check how much you stretched it. Again, that's a relatively low-cost approach. So you take a bolt, and from the head, you drill a hole, a blind hole. You don't go all the way through, but kind of close to the bottom of the bolt. And then you can drop a depth mic into the hole and make a measurement, and then you can torque it and make another measurement, and you directly measure the stretch of the bolt. So that is another way to do this. Excellent. Proteum says, the real question is, why don't we have vice screws with the smart bolt tech built in? That's a super good question. So this a little hashtag not sponsored here, but a little commercial for the Tecton wrench. That is why I have the Tecton wrench. I needed a small torque wrench for tightening vices. So when I made the Kinetic Precision B200 balancing rings, go to pfg.gg/ring. I needed a way to very reliably and very consistently tighten the vices. On station number 1, it was the first op, and I designed these very sharp work holding posts that are compatible with the Mighty Bite Versa grips, but I had to design my own for reasons. It had to be higher than the vice jaws, and I needed to have those consistent. And the second one was a set of soft jaws for operation 2. Same thing. I needed them to be consistent, because you could literally change your position of your part in the vise if you're not consistent. So I bought this Tecton, this nice little guy for tightening the vices. Didn't take much, especially in op 1, because they were literal knife edges. And I forget what the number was. I think it was, it's probably still set on here. 100 inch-pounds was where I wanted this thing to click, and it does a very nice job. So I get this order the other day from a company. Guess which company I got an order for PFG Stones? From Tecton, and I made a new friend there, and that's really cool. So I love my my Tecton wrench for that application. Evil says, reminds me of the hydraulic vice screw somebody was showing last week. Regular vice screw with a finer pitch screw that pushes on a hydraulic cylinder inside of it. And if that has a relief valve, you have repeatable torque. That's a good idea. I think it's pretty important that you use the tools you have, and a torque wrench gets that job done really well. So just to put some numbers on things, Proteum says Tecton is an instant recommendation for any hand tools, great quality tools, very open about where each thing is made, US, German, or China, and fantastic warranty. So I did talk to my contact about that. And honestly, when I bought this, I did not know where it was made. And this is made in Taiwan. Now, those of you who deal with machine tools know there's a difference between Taiwan and mainland China, despite the fact that mainland China would like you to believe otherwise. But it's a very high quality tool, and they are based out of Grand Rapids, Michigan. So it's a very interesting company. I'm very happy to have been hit in the head to pay attention to this company because I really like the tools. And Brodium says we use that same torque wrench for pull studs. Yeah, it's a lovely little device. In fact, I might get another one. So now that we're talking about, so let me give you some numbers, by the way, for the 440 screws that I was doing. So this is right out of the NASA paper, and there's literally hundreds of pages of tables if you pull up the document. Again, link in description. But in 6061 T6 aluminum, which is what we built our thing out of, length of thread engagement equals 0.375, which is about right. This is not to be used for flight hardware. There's a column here called assembly torque, which is what I used. And that was for 440, that was 9.9 inch-pounds, or 1.2 Newton meters. So just remember, when we're talking about torque, I have here an Allen wrench to demonstrate what we're torquing about. If you put a certain amount of force on your Allen wrench, a certain distance away from the rotation, that force and that distance comprise the amount of torque you're putting on the fastener. So in the US, for example, we use typically inch-pounds or pound inches. I say inch-pounds. And metric is Newton meters. So meters, of course, you know what a meter is. Well, what's a Newton? A Newton is an amount of force. And a friend of mine taught me this many years ago. If you imagine holding an apple in 1G, okay, the amount of force that an apple puts on your hand is about 1 Newton. I bet you're not going to forget that, okay? It's about a quarter pound. So that's a Newton's worth of force on your hand from the apple. So Newton meters. Now, it also goes down into ounce inches and things. So you have to be wary of what units are being quoted. For the 632 screws, same thing, in aluminum, it was 18.7 inch-pounds and 2.1 Newton meters, according to NASA. We have another cool link for fasteners that Robin just put in the chat. I will review that, Robin. Thank you, and that might make its way into our reference channel. Okay, so then I picked up Machinery's Handbook. Talk about dangerous. There were some very interesting tidbits. So this is 27th edition Machinery's Handbook, page 1495 in your hymnals. So they talk about all of the errors that we covered, all the errors, and they basically said, "Oh, here's my favorite part." So what if you're putting together an assembly of your own design and you don't really know how to calculate the number for the torque based on the fastener you're going to use and the thing it's going into and all that kind of stuff? What do? Well, according to Machinery's Handbook, the proper torque to use for tightening bolts in sizes up to about a 1/2 inch may also be determined by trial. Test the bolt by measuring the amount of torque required to fracture it. Use bolt, nut, and washers equivalent to those chosen for the real application. So they're getting away from this whole chain of errors by saying, just put together the thing you're going to put together the way you're going to put it together and torque it until it breaks. Then use a tightening torque of about 50 to 60% of the fractured torque determined by the test. The tension in a bolt tightened using this procedure will be about 60 to 70% of the elastic limit yield strength of the bolt material. And then it goes on to, so if you dig deep enough in the writing in the machinery's handbook, they tell you what to do. Set up exactly your situation with your materials, your fasteners, okay, and torque it till it breaks. Divide by 2, write that number down, and you're all set. Now, that requires that you measure the torque. Now, a torque wrench limits torque. It doesn't measure torque. So the way you do that is with, it could be with a weight on a wrench. You know the distance from the rotation. You put a weight on it. Another way to do it is to stand on a scale as you're pushing down on a wrench and slowly and observe the weight on the scale. But basically, you have to come up with a way to measure your torque and up to where it snaps, and then divide by 2. There was an old joke from motorcycle mechanics. The correct amount of torque was to, and of course there were aluminum engine blocks and aluminum everything, was to torque it until it goes soft and then back off 1/8 of a turn. Which, according to the curves that we've been looking at, is not so crazy, but it's a joke. Unfortunately, I looked in the black book, which a lot of us have, this little reference book, and while they did have a torque conversion chart between foot-pounds and Newton meters, they didn't really have a lot of information on torques. So I did leave the link to the NASA paper in 2 places. You should be able to find it. Dale says, remember, nothing holds like a good cross thread. Also known as a locking bolt. Isn't a cross thread and a locking bolt same thing? Isn't that the same thing? Just checking. Try not to over torque your screws, but definitely don't under torque your screws. The number one failure that I have found is over torqued fasteners. Is people yoinking on fasteners until they do fail, until they're maybe a hidden failure. If you had to err a little bit on the negative side. And Protium says, who needs thread locker when you have cross-threading and ugga-duggas? And the NASA paper was specifically written to overcome ugga-duggas because they're not traceable to the National Institute of Standards and Technology, and we like them. We like you guys. So that's a little bit about torque. I hope you didn't get over-torqued. You think about it more. Every time you tighten one of those fasteners, I want you to think about, oh, I'm putting torque on this thing, and I could feel, it. And now I think I'm stretching the thing. And then when you rip the threads out, you can say, oh, now I've ripped the threads out. You'll be fine. I think in the future we need to have a segment specifically on all the Loctite products and the thread lockers and all that kind of stuff, because that's another deep dive into a whole other situation. Okay, I think we covered it, man. We've covered everything you need to know about torque, but was afraid to ask. I think next week is a normal Sunday. It looks like a normal Sunday, so we should be back next week. If you guys have PFG Live with Henkel, So I wouldn't mind finding my Henkel representative. So Henkel bought Loctite. This was, I don't know how many years ago, but Henkel owns Loctite now. And their website is excellent. And in our reference channel on the Discord server, we do have either the PDF file or the pointer to the PDF file, which is a big poster of all the Loctite stuff and what to use where. I'm up to about it has to be a dozen different Loctite products down in the shop. So oh, Carl says, or use an old torque wrench that does measure torque. Yeah, this torsion wrench does have the advantage of displaying torque as you go, but it's not exactly high precision. All right, guys. Well, this has been a hoot. We will probably be continuing the conversation in the after party roundtable. You guys are welcome to join us in our Discord server. Just go over to pfg.gg/discord, and it'll tell you how to get on it, and it'll send you an invite. If you're looking for something flat or something to make something flat, head over to PFG.Stones.com, where we just finished up some 4-inch round aluminum oxide PFG stones, which came out absolutely magnificent. I really like the rounds. Ask me why, and I'll tell you. I put up a short video on Instagram, which is just yet another video of me cleaning my 6-inch PFG stones with WD-40 and cardboard. If you want to learn more about anything, just head over to pfgstones.com, and there's also a contact form if you want to shoot me a message. And with that, I'm going to say have yourself a great rest of your Sunday. We'll talk to you guys soon. Get flat, stay flat, and we'll see you next week from the Flat Cave. Take care.